Okay, for example 4, it says use similar triangles to find x and y. And it's going to want the exact values of x and y here, so it might not specifically say that. But usually it does, but sometimes it'll just say find them. They always want the exact answers. Do not give me decimal approximations on this. All right? Use similar triangles to find x and y. What I have is a 45-degree angle and a right triangle, which immediately makes the other angle down here in the corner 45 degrees. We've already done this type of problem with a 30, 60, 90 right triangle where they said use similar triangles. They only drew one triangle. Okay, you can't do similar triangles without two triangles. So the fact that every 45, 45, 90 right triangle is similar to that one is what we're going to use. And just like the 30, 60, 90 problems, I want to draw this the same way that's drawn. So the 45 up, 45 down right, and the right angle is bottom left. Okay, if this was turned some weird direction, if this was like that, then I want to draw this one like that. And of course have your numbers turned so they're not looking weird. But anyway, but again, you draw yours the same way that one's drawn. All right? And then you got your similar triangles and you have your matching sides. So y matches up to 1, x matches up to 1, and 7 matches up to the square root of 2. Now, can everybody see very clearly that x and y would be equal to each other here? So I don't have to find both x and y. If I find one, I can just put x equals y equals the answer, right? So if I just focus, let's say, on the blue and the red, y and 7 matching up to 1 and the square root of 2. And I make a basic proportion out of this. I'm going to put 1 on top. I'm going to put the square root of 2 on top. I could have just easily put 1 on bottom and square root of 2 on bottom. It doesn't matter where you put them as long as they're in the same place. So both of these measures, 1 and square root of 2, came from this triangle. Both go on the same side of the fraction. Y matches up to 1, so 1 and y go on the same fraction. 7 matches up to square root of 2, so 7 goes in the same fraction as square root of 2. If I were to cross multiply this product, the square root of 2y, is equal to that product, 7. And if I want to get y equals, I simply divide by the square root of 2. And that gets me what y equals, and that's not the best form of y, right? So the best form would be multiply top and bottom by the square root of 2, because we don't want radicals in the denominator. So I end up with y is equal to 7 times the square root of 2 over 2. I know x equals y, so that's how we get x also. It's also known as an isosceles right triangle. Right. Let me show you one other thing you can do on this, if you wish. Okay. If we're all in agreement that the x and y are equal, right? If I called that x, leg squared plus leg squared equals hypotenuse squared. So 2x squared is equal to 49, which means x squared equals 49 halves, which means x is equal to the square root of 49 over the square root of 2. That also works. That gets you the 7 times the square root of 2 over 2. I don't care how you get the right answer, but I will say the similar triangle idea is kind of good. So it tends to be more efficient once you get used to it. But know the Pythagorean theorem is still alive and well and works. So take your pick. I don't care which way you do it. The other thing they do sometimes on these problems is they'll give you this, but not that or that. If that's 9, this is also 9, and then just do the proportion, and you'll get the answer. So x and y are equal to each other, but the hypotenuse is not. So keep that in mind. Whatever they give you as a side, it's not always going to be the same answer. If they don't give you the legs, they'll be the same answer. But they don't give you a leg and a hypotenuse, then